So 6.4, this is what we will be doing is we will using the normal distribution, a normal distribution to approximate the binomial distribution. Okay, so basically this is what we have is, again, if you remember, your binomial distribution is if you do perform something and you have only two outcomes, right? Meaning if you flip the coin, and again the coin is either a head or a tail, right? So now they want you to see, which is in chapter 5.2, we do the binomial PDF and binomial CDF. So this is what they tell you is, well, can we use our normal distribution? Can we use our normal distribution to do that item without doing the binomial PDF or binomial CDF? Can we use our bell-shaped curve to approximate this binomial distribution? And the answer is yes, right? That's why we have this chapter. But before we can perform it, we have to do some testing. We have to make sure that it's fit our condition. So what is the condition here? Well, the condition is this, which is you need to have in terms of, you have to take the n times the p, and that number have to be bigger than 10, bigger than or equal to 10. Or the second item is n times 1 minus p, that number have to be bigger than or equal to 10 also. So if you test it out, and what is the p? Well, the p is the probability of success, right? Or the probability of something come out, and the n is the total. So if you can multiply the two, and that two number bigger than 10 for that item, or that two number n times 1 minus p is bigger than 10 or equal to 10, then we say, okay, we got a green light. We can use this. We can use this normally distribution to approximate the binomial distribution. Okay, just like in 6.2, before you can go ahead and convert your standard deviation to become a sample standard deviation, the n, which is your sample, have to be bigger than 30, right? This one here, this two item have to be bigger than or equal to 10. And just like before, like I mentioned to you guys, the two things that we need in chapter 6, before you can use the normal or the inverse norm, this is the two items we need, which is we need the mean and we need the standard deviation. So in 6.4, you have to find the mean and you have to find the standard deviation, okay? In 6.1, 6.2, they give it to you. You have to do some adjustment. This one here, to find the mean, you just take the n times the p, which is, again, that's your binomial distribution, or the mean and the variance and the standard deviation with the binomial distribution. And to find the standard deviation, you need to take a square root of n times p times 1 minus p, okay? Square root of n times p times 1 minus p. So those are the two, or those are the four items that you need in order for us to using the normal distribution to approximate the binomial distribution, okay? So again, another terminology that we need to figure, which is, again, this is all they tell you to do. This is basically all that they tell you. All that I just told you is this the requirement, right? The requirement is, again, the n times p have to be bigger than 10. N times 1 minus p have to be bigger than or equal to 10. And again, if those two items happen, then we need to find the mean and we need to find the standard deviation, okay? So again, most of the time, ladies and gentlemen, this two number will be bigger than 10. They won't give you something that's smaller than 10 and then you cannot do it. So most of the time you can do it. But here comes the problem, right? Here comes a small problem is, if you remember, your binomial distribution is we only deal with a discrete data. Discrete data meaning, again, you flip one time, you flip two times, you flip three times, meaning it's a counting item, right? It's fixed, 1, 2, 3, 4, 5, 6. We cannot do 1.5 of a time, right? So that's what, and when we do a normal distribution deal with a continuous data, meaning there's an interval that consider of this item here. So what do we do, or how do we convert from discrete to continuous? Well, to make this approximately, again, approximately is basically we try to estimate, right? We try to estimate what is the percentage. To make this adjustment to be accurate, we have to adjust our endpoint, which is we have to change in the interval to become this. We have to correct the endpoint for say. Okay, so how do we correct the endpoint? That's that's one of the most challenging part to comprehend today. Okay, so looking at this thing here, which is suppose we have this. Suppose we're not going to do this problem, but this is just an example we have. Is suppose a fair coin is tossed 100 times, and let's X represent the number of heads that come out, right? And then X have a binomial distribution with the n equal to 100, and the probability is 0.5 because 50% head, 50% tail. If we want to compute the probability of X is between 45 and 55, as you can see, the probability will be different depending on if we include the endpoint or excluding the endpoint, right? So looking at this thing here, this is basically the question is, if I flip this coin 100 times, what is the probability this coin land on head between 45 times and 55 times? That's the idea, right? And if you look at this thing here, which is again, if you can see, looking at this item, and if we don't include, and hopefully you can see that right here, we don't include the endpoint. Do you agree that this one here, probability of 45 less than X less than 55, because they don't have an equal sign, we don't include the endpoint. And if you look at this thing here, this is my 45 endpoint to 55 endpoint. Everybody see that my red box, that are my 45 endpoint to 55, 45 all the way to 55. But because I don't include the endpoint, everybody see that I have to make this item a little bit smaller, right? Which is my blue ink here. In order to exclude this endpoint, I have to move inward. I have to make it smaller so that I don't include the 45 and I don't include the 55, which is again, as you can see, this is what we need to do. And in short, ladies and gentlemen, in short, all you do is you either add 0.5 or subtract 0.5. Okay, we don't add any other number, we don't subtract any other number. All we do is we try to move inward by add 0.5 or outward by subtract 0.5. Okay, and again, looking at this thing here, if you look at this item, we know that down here, this item here, we include the endpoint. We include the 45 and we include the 55, which is, as you can see, my red item, my 45 to 55 is here. To include this thing here, I have to make it a little bit bigger, which is I expand my interval out, which is my interval now become 44.5 and 55.5, okay? Like I said, we subtract 0.5 here and we add 0.5 here, which is we try to make this interval bigger so that we include the item that we need to, or we include the endpoint, okay? So again, I know it's a little bit puzzling. Let me go a few more slides, and then hopefully after the third slide, it'll be a little bit easier. But again, the next slide is just tell you the same idea. Is if we have, well, let me go to, I'll be back. So this slide here, which is, this is kind of like your note card, right? Your cheat sheet, right? So this is basically, this is what they tell you is if your binomial distribution is this item, which is find the probability of X is exactly equal to some number A, then to use the normal to approximate that, you have to take A minus 0.5 and A plus 0.5 so that you can include that X number, okay? And again, if you're looking for X is greater than whatever A is, whatever the value of A, to use the normal distribution, which is again, basically this is what they tell you is find the probability of X is greater than or equal to, which is we include this thing here. So again, we have to subtract it to make it a little bit bigger, okay? And again, in this case, it's not equal to, we just find the property of x that is greater than, not equal to, right? Just greater than. To make it a little bit less, we have to add 0.5, okay? So again, same idea is, this is just basically, if you do your homework or do your quiz, on your test also, if you click on the formula sheet, they will have this portion in that formula sheet for you, tell you that if you have a binomial and you want to use a normal, this is what you need to do. You either add 0.5 or subtract 0.5, okay? So again, same thing with the previous slides. The previous slide is basically tell you that, again, if you have x is greater than a, all you need to do is, again, this is where my x is at. For instance, this is where my x is at, right? And I want to include this endpoint, I have to subtract 0.5 to make it a little bit bigger to include that. Same thing go, if this is my b, if this were to be my b, and to make this, if I want to include my b, I have to add 0.5 to make it a little bit bigger, okay? So again, this thing here, as you can see, if we want to include, we have to subtract and add. So again, let's take a look at the example. And then hopefully this example, bear with me, I know it's a little bit fuzzy and confusing right now, but again, bear with me right here. Let's take a look at this item, not this one here, but again, this one here is just basically tell you the step that you can take, or the step that you want to take to use a normal distribution to approximate the binomial, which is, again, first we have to check the condition to see if this two item bigger than 10, bigger than or equal to 10. If that is worked out, we have a green light. Once we have a green light, we need to find the mean and we need to find the standard deviation. Reminder, the mean is the n times the p, that's your mean. The standard deviation is a square root of the n times the p times the n minus p. And then you have to determine your endpoint, which is either add 0.5 or subtract 0.5. And then you have to sketch your normal curve, which is draw your small mountain or your bell-shaped curve, and then label your endpoint, and then ask yourself, do I shade it to the left or do I shade it to the right? And then lastly, we need to use our technology. We need to use, for us, we don't, for us, we try to save time, so we will use the technology rather than the table, okay? The table work too, it's just, so let's take a look at this thing here, which is this item, okay? So for instance, let's say that in this example one, they say n is a sample size, b is the population proportion of a successful item, and x is the number of items you wanted to come out, right? Using the normal approximate to find the indicated probability. So pretty much, again, this thing here, as you will see, most of the time or all the time, they will tell you, they can spell it out for you, and they say use the normal approximation to approximate the binomial. If they really tell you that, then you know that you are in 6.4, which is we have to use the approximation, or sometimes they just say use the normal approximation. Normal approximation, that should be a keyword or a hint that you have to use your normal to approximate the binomial. Okay, so now, if you see this thing here, first of all, let's check our criteria, check our condition, right? So if you check your condition, this is what you do is you take n times p, which is n times p will give me 115 times p, which is 0.6, 98, that's bigger than 10, I'm good to go, right? And n times 1 minus p, which is 1 minus p will give me, again, 15 times 1 minus 0.68, which is, again, 16.1, I'm good to go. But I see that we have green light. We can use this normally to approximate this item. So now, what do they ask us? Which is they ask us to find the probability that x is greater than 98. So how do we find the probability of this x is greater than 98? right? Just assume that this is what you have is, again, we flip the coin 115 times. This coin is loaded, right? Meaning one side will come out more than the other. Let's say the probability of the head come out is 86%, and the probability of the tail come out is 14%, which is you flip them, one side is heavier than the other side, and it's come out a little bit more, right? A lot more, right? So now the question is, given this item, what's the probability if I flip this 115 times and 90, as you can see, the number of head come out more than 98 times, right? Meaning 99, 100, 101, 102, 103, so on and so forth, if we were to do a binomial distribution. So looking at this thing here, because we have a green light, this is what you need to do. The difference between 6.4 versus 6.2 is 6.2, they give you the mean, and you need to adjust your standard deviation, right? 6.4, you have to find the mean, and you have to find your standard deviation, which is, again, your mean, which is the same as before, which is n times p, which is, again, 115 times 0.86. That's your mean. Your standard deviation is square root of n times p times 1 minus p, which is 115 times 0.86 times 1 minus 0.86, which give me a square root of 13.846, which is 3.721021365. So one thing I want to point out is, if you use the decimal, make sure you use a lot of decimal, meaning at least 6 or 7 decimal places as possible, or all of them if you can, okay? Because if you round up and you give them 3.7, your answer will be a little bit off. And again, if you took the test, I have a lot of students send me email related to the routing. And again, if you use the wrong number, it will come out to be a little bit off. So try to use, don't round in the process, only round at the final answer. So here comes the problem, ladies and gentlemen. We got it. We got the mean, we got the standard deviation. The next toughest item is, what is my end point? Okay, so let's take a look at this thing here, which is, again, they ask you to sketch them, right? So let's say that this is my sketching of this item, which is my mountain, right? And then you just put a line through it, right? Put a line through, let's say that this is 98, right? And now x is greater than 98. Everybody agree that x is greater than 98. So what side is greater than 98? Do you agree that I have to shade it on the right hand side? Anything to the right of this is bigger than 98. Agree? So looking at this thing here, again, it does not have to be precise, right? Just put a line and ask yourself, where do I shade it? Do I shade it to the left of that line or to the right of that line? So looking at this thing here, this is my 98, okay? So now the next challenge is, do we include this 98 or do we exclude that 98? Which is, as you can see, we are excluding the 98, right? Meaning if we excluding this 98, you can see that I cannot move it to the left, right? Because if I move it to the left, I include a 98. So to exclude a 98, everybody see that to exclude a 98, I have to move it to the right, right? I have to, to exclude this thing here, I have to go this way, right? Meaning, again, I throw away the 98 because this thing here doesn't have equal to 98, which is, again, same idea here, which is, if we move it to the right, and this is why I tell my students is to make it easy, right? You can look at your chart prior to this thing here if you want to, or to make it easy, this is all you need to remember. If you move it to the right, you add 0.5. If you move it to the right, you add 0.5. If you move it to the left, you subtract 0.5. Okay, so again, to go back to what I just said, if you move it to the right, you add 0.5. If you subtract, if you move to the left, you subtract. So if you don't remember that, if you go back to your note, right? If you go back to this thing here, you see right here, this is what we have, or this is your layout, right? We have x is greater than, x is greater than 98, right? Probability of x is bigger than 98, which is what do they tell us? Well, if it's x is greater than 98, all you need to do is add 0.5. Everybody see this concept, or this is what this chart tell you, okay? So once we have this, which is again, once you identify, however you identify it, if you remember, go to the left, I subtract, go to the right, I add, then that's fine, because now once you have the endpoint, everybody see that now your endpoint is not 98, but your endpoint is 98.5. That's the smallest endpoint, and the bigger endpoint is 10 million, right? And my mean, what is my mean? My mean is 98.9, and my standard deviation